Welcome to Pomodoro Joe for Tuesday, May 9th, 2023. Today we're looking at LeetCode problem 54, spiral matrix. This is a medium problem. Given an n by n matrix, return all the elements of the matrix in spiral order. So it looks like we'll output our result as an array. And so we'll start at 0, 0, work our way all the way to the right, then we'll go down, left, up, right, down, left, up. So we keep doing that into spiral and return our result. Okay, so we'll put 25 minutes on the Pomodoro timer and we will get started. Now before I start on this, I'll point out there are a lot of different ways you can solve this problem. I am going to approach this from a very straightforward way, just so I can explain it simply. At the very end, if there's time, I might show you there is a one-line solution to this, but it's complicated, so I probably won't go into it. All right, so for us, we will have some return value. That'll be our result, and it's going to be an empty array to start with. And at the end, we'll return our result. Okay, so I'm just going to do exactly how they outlined it here with these arrows. I'm going to start at 0, 0. I'm going to work my way all the way across this first row. When I get to the end of the first row, I'll work my way all the way down this first column. When I get to the end of this first column, or I should say last column, I'll work my way left until I get to the first column. Then I will work my way up until I get to what is I'll call it my new first row. So once we've finished this row, we're done with this row, and this second row becomes I'll call it the minimum row. And we'll keep going. Now, let's just break this out into the pieces that we'll need. So we'll need to have our current row and column, so that's pretty straightforward. So we'll start at 0, 0. So this will just keep track of our current row and column. Now I also need to know my current minimum row and my current minimum column. I'll also need to know my maximum row and my maximum column. So I'll get those here too. So the min row will be 0, and the max row, let's see. In our matrix, the first index will tell me the row, and the second index will tell me the column within the row. So our max row will be the length of just our matrix. That's going to tell me how many rows there are in the matrix. And I actually want this as an index, so I'm going to say -1. Because this length returns the number of rows there are, I want to know the index, which is 0-based, so I'm going to say the length of the matrix -1. All right, now the minimum column that we have, well, that's going to be 0. And the max column, well, that's going to be this first row's length. So basically the length of our matrix at index 0. That's the first matrix row. So that's going to be length. And again, I want the index, so I'll say -1. Okay, starting to take shape here. We've got our current row and column. We've got our min and max, so we kind of have these boundaries here. Now what else do we need to know? Well, we need to know when we get to the center. How do we know when we get to the center here? Because we might get to the center on a single cell. We might have, yeah, it's not really centered in this one. So I think what I'll do here is I'll just keep track of how many cells we've actually gone through. So if we just know how many cells there are in our matrix, and we keep track of how many cells we've gone through, we'll just have a count. When we reach the end of our count, well, then we're done. Let's see, so we'll call this. So our cell count will be, well, that's going to be the length of the matrix at 0 times the length of our matrix. So this might be better done if we just grab our matrix row. Let's do that actually. So our cell count will just be the length times the width. And that's going to be the number of rows. That's the max row. But I need to convert this back into an actual length and not an index. So that's the max row +1 times the max column +1. And then we'll also keep track of our current count. And the final piece, we need to know which direction we're going. So if we're going left or right or up or down. So I could keep track of this using some variable that's like left, right, up, down. It could be like an enumeration or something. I'm actually going to keep track of the delta. So what is the delta I'll be adding to my row and column at each step along the way? So I'll call this like delta column and delta row. Let's see. If I just start at 0, 0, and my deltas are 0, I'm not going to be moving. But it looks like I want to go this way first. So if I'm going this way, these are advancing columns. So I'll be going from 0, 0 to 0, 1 to 0, 2. So my column will be an offset of 1. Now one thing to note here too, this top left corner is 0, 0. So x gets bigger as we go right, and y gets bigger as we go down. Or the column gets bigger as we go to the right, and the row gets bigger as we go down. Now finally, we have all the pieces that we need. We have our boundaries, we have our counts, and we have our offsets, and we have our current position. Now finally, we can actually get to the work. Now I'll say while our count is less than our cell count. So while we haven't gone through all of our cells, well, we'll just start adding cells to our result. So our result will append. Let's see, what do we append? Well, it'll be the matrix at our row and column. And then since we've added some cell to our result, we can increment our count. Next, we advanced our pointer here. Which cell do we go to next? That's just going to be our current cell plus these offsets, these deltas. So let's see, our row will be offset by d row, and our column will be offset by d column. All right, so now we're slowly working our way across this matrix. At some point, we're going to get to our end. Now, where do we figure out, or how do we figure out that we've got to the end of this sort of left or right movement? So in this particular case, if we're going right, we know we've reached the end if we've stepped outside of the bounds, if we're greater than our max column. All right, so if our current column is greater than our max column, then we've stepped outside. We've gone one step too far. So we've just added this 3 and we've stepped outside. That's one step too far. So now we have to switch everything up. Let's see, there's a couple things we have to do. I guess the first thing we'll have to do is figure out what do we do? How do we change our direction? Well, we do know we have to change direction here. So let's change our direction. So we're no longer changing our columns. We're going to suddenly shift and start going down. That means our column stays the same. And we're still in this last column here, but our row is advancing. So our d column becomes 0 and our d row becomes 1. Because we'll be advancing down to the next row, the next row, the next row. We've also stepped 1 too far, so we actually have to take a step back. So we actually need to reset this current column. But before we do that, we are done with this row. So we've finished this top row here. We've got to the end of this row. So we actually can advance our row. Our minimum row here is no longer the 0 row. We're done with this row. So our min row becomes row 1. So let's see, our min row plus equals 1. And then we kind of want to reset. We were just at this 3 and we stepped 1 too far to the right. So let's reset our position to the 6. So let's say that row is going to be at this new min row. And our column will be at our max column because we're staying at our max column here. All right, so that takes care of one condition. That just takes care of once we've finished up our first row, or actually this takes care of any row where we've moved from left to the right and we've reached the end. Now we need to look at what happens when we go down. All right, so for this one, we'll be advancing our rows, and at some point we'll get to the very end and we'll step outside and we'll be outside of our bounds of the max row. So let's see if our row is greater than our max row. Well, very similar kind of thing. Now we're going to start moving left. So our D row becomes 0. We're no longer advancing in rows. We've got to the end. We want to stay at this bottom row, but we'll be moving left. So our D column is -1. Now we're stepping back to the left. Okay, and we're done with this max column. We just finished this max column, so now we have to say our max column minus equals 1. So this column becomes our max column. We are done with this column, and our new max column is this column over here. And again, we need to reset. We finished with this 9. We stepped 1 too far, so we kind of want to go back to this 8. So let's see, that's going to be our new row and column will be the max row and the max column. All right, and we have 2 more to do. So that takes care of going from left to right and from top to bottom. Now we have to take care of going from right to left. So that means we're going to step outside and go past our lower bound on the minimum column. All right, so if column is less than our min column. All right, again, we'll take care of our direction change first. So we were going from right to left. Now we're going to stop changing our column. We're going to stay in this minimum column, and we'll just be going up the rows, which means -1 steps in the row direction. All right, and now we've finished with this maximum row. So now our max row gets reset. And again, we need to reset our current position. So our row gets reset to, let's see, what's our row now? We're at our maximum row. And our column becomes our min column because we're way over here on the left-hand side. All right, let's see. Looks like I've done pretty much row and column except for up here. I'm switched the order, so I'm going to switch this around just to keep things clean. So row, column, row, column, row, column, row, column, row, column, row, column. All right. Now the last one. If we're going up and we step outside, we go past our lower bound on the row. So this is, our row becomes less than our min row. All right, again, we need to change direction. Now we'll be going from left to right. So our D row gets set to 0. We're not changing our row, but we're changing our column, and that goes up by 1. And again, when we get to the end of this column here, we're done with our min column. So our min column can advance. And then we reset our current row and our current column. So the row becomes our min row, and our column becomes our min column. Okay. All right, let's just take a quick look. Everything should have sort of matching or parity with the other. I guess each one of these should have sort of a matching or an opposite. So let's look. We have row goes up by 1, then it goes down to 0, then it goes down by 1, and then it goes to 0 again. All right. Columns, we're not advancing our columns. We're not going to advance our columns here. Then we go back to the left. Then we don't advance the columns, and then we go back to the right. Cool. Min row, max column, max row, min column. All right, that looks good too. And then row, min row, column, max column. Row, max row, column, max column. Row, max row, column, min column. All right, those are opposites. And min. All right, so this is a lot of code, but it's not that tricky. It's just a little bit, you just have to sort of keep track of all these little pieces. Let's see if this works. And it works. Let's see how we do. And we pass. We don't do very well. We only beat 12% for runtime and 6% for memory. So this is definitely not the fastest algorithm. There are probably certain things you can do to speed this up. You could, let's see what we could do here. We probably could do something with these rows and column directions, maybe make them tuples, and then we can just add the tuples. We could probably maybe initialize this result. So instead of doing all these appends, we could just set the values. Actually, let's try that. That could be interesting. So let's say this is like 0 times, I guess we don't have our count yet. So let's put this down here. Now, I don't know if this will actually help us, but I think it might be an interesting thing to try. And then instead of appending, we'll just set the value at the result for this count as the index. So this might help sort of like pre-allocate our result, and then we don't have to worry about all these appends. Let's see if that makes a difference. Not really. 9% for runtime, 5% for memory, as opposed to 12% for runtime and 5% for memory. So actually, it does worse. All right, actually, since we're here, I will show you what the one-line solution. Let's see if I can find one. Nope. Here we go. So here's a one-line solution. Actually, I don't know why they need this and. That's interesting. This might bear some looking into. So for this one, you'll actually be popping the 0. Essentially, that's the first row out of the matrix, and you're unpacking it with this star. So that's basically taking each element and just putting it into its own list here. And then we'll be appending to that list. So this grabs the first row and basically creates a new list out of it. Then we'll be appending, let's see, we'll be doing a recursive call on spiral order, unpacking a zipped version of the matrix with a -1 step. So that's reversing the matrix. So zip will interleave our elements, and this will make them reversed. I'm not totally sure how this works. If you're really interested, leave a comment and I'll actually go through this. How about that? Leave a comment on this video. And if you really want to see me break this down, I will break this down and show you how it works. All right? Until then, I think we're going to stick with our 12% here. And that gives you a chance for major improvements. Grab this base code and make it better. All right? All right, well, that's it for me. Hope you had fun. Hope you learned something. Hope you can go out and write a better solution than I did.